Hello everyone, welcome back to the channel. In this video lecture, we shall solve this problem: design, add and search words data structure. In this problem, we have to design a data structure that supports adding new words and finding if a string matches any previously added string. So we have to implement a word dictionary class. This class must have a constructor word dictionary which initializes the object of the type word dictionary, and it must have a function addWord which takes in the argument word and adds this word to the data structure such that it can be matched later. Then it must have another function, search function, with a boolean return type. It returns true if there is any string in the data structure that matches with this word, otherwise it must return false. Word may contain dots where dot can be matched with any letter. So we have 26 letters. We are taking into consideration all the words which contain small case English letters. So we can replace the dot in the word with any of the 26 characters that we have. Let's better understand the problem statement using an example. So this is an example. These are the commands that we are given in the form of array, and these are the words that we have to insert or search. The first command is word dictionary. It says, okay, initialize an object of type word dictionary, which is the class that has the functionalities of search and add. Then we have add word command. It says that add this word bad into the data structure. Then we have addWord command to add this word into the data structure, and so on. Here we have a search command to search for this bad data, if it exists in already added words or not. Then we have search command to search for this word that is bad, and it will return true because this bad has been added here. Then we have search and followed by another search to search these words. So this word is .ad, that means find me a word which can start with any character but the last two characters must be ad, and the answer would be yes because we have dad. We can replace this dot with d, we can replace this dot with b, we can replace this dot with m, we can replace this dot. Okay, so the answer for this will be true because we have this word in the dictionary. Then we have b dot dot, where these two dots can be replaced with any character. The answer for this will also be true because we have bad here. So these two dots can be replaced by ad. Hence it will give me true. So this is the functionality that we have to implement in our data structure. So which data structures gives me the functionality to add and search for words? So we must have two functions. The first function is addWord function. It inserts the word into the data structure, and a search function which search for the word in the data structure where the word may contain a dot which can be matched with any letter. So this type of functionality can be implemented in Trie data structure. So what is a Trie? It is a data structure used as a dictionary to search and insert strings. How does a typical Trie node looks like? So this is a typical Trie node. It contains an array of 26 characters where each position represents a character. Then we have a boolean variable in this node which contain boolean values, and it is used to mark the end of the word. If I want to store C here, then I will mark C as true here, and if C, character C, is the end of the word, then I will mark true here. This is how a typical Trie node looks. The next question is, how does this Trie node stores a word? Let's see that. So this array basically is an array of 26 pointers where if I stand at any particular character, let's say I stand at C, and C is present in the word we are searching, then this C, the pointer at this location, must point to the next node of the trie which contains next character of the word. Let's better understand using an example. Let's say we want to store DAD into a trie. So we have three characters, hence we require three trie nodes. In the first node, I want to store D, and I go to D and I store a pointer which points to the next node of the trie which contains A. So this position, that is D, contains a pointer which points to the next node which contains A here, and this position contains a pointer to the node which contains D, that is the next character. So that's where this pointer is pointing to, D. This is the third character of the word, and I mark here true because this is the end of this word. D is the ending character, hence this is marked as true while these are marked as false. This is how a string is stored in a trie using pointers. Let's see how we can implement this trie node. So this is the class which represents a trie node. It contains a boolean variable which is used to mark the ending of the word, and an array of size 26, an array of pointers with size 26, and the pointers are of the same type as this class. Then this is the constructor for this class which initializes each boolean variable with false as a default value and all the pointers as 0 or null pointers. So this is how we implement a typical trie node. Let's see the function, the implementation to insert a word into the trie. Let's say we want to insert DAD. Then in this function we start with the root node, that is the first node. So this is the root node. Let's call it node number 1, and we iterate over this word starting from the first character, and we are standing at this node, that is the root node. That means D must be present in the root node. So we initialize node with the root and we iterate over the word, and we check if this character, that is D, is present or not. If it is not present, so since we are adding this word, this will contain null value because D is not present here. We want to insert D here. Hence, this must contain null initially, and we want to store at this position the pointer to the node number 2 which will contain A. So this is what we want to do. So we initialize another node here, trie node, and we store that pointer at this location. Now this points to another trie node, and we move our node which was pointing initially to root node. Here I initialized it to root node to the new trie node which I created here. Now my node is pointing to this node, and I move to next character of this word, that is A, and here I check A is again null. Then I create another node, that is this node number 3 here, and I initialize, and then I create another node, and the pointer to this node, that is new node, is stored at this location, that is at A. And finally we move to D. Then the node is moved to this node and we move to character D. Then we see that then I create another node for this character, and this D, the pointer at this D, will point to node number 4. Now I exhaust my word and my node is pointing to this final node here, and I break out of this loop, and finally I mark this node as the ending node. So the boolean variable in this node will be marked as true, as this node represents the ending of this word. That's how the add function works. Let's discuss the time and space complexity for this function. The time complexity for the add word functions is big of k, where k represents the length of the word that we are inserting. Then the space complexity is big of n, where n represents the number of nodes that I require to store the given string. Let's see how we can search in the given try. Here, let's say we want to search DAD, and we assume that this word is already stored in the try. Then this is node number 1 that we call as root node. We start from the root node and we go to character number D and check if this character points to some other character or not. If this character contains a pointer which points to another node, then we move one character ahead and we move to that. So this character, that is D in this node, is pointing to this node. Now we are pointing to this node and we are standing at character number 2, that is A. Now we check if character A in this node is null or not. That means whether it points to another node or not. If it points to another node, then we move to that node and we move our pointer to the next character. Then we see if the pointer at position D is pointing to some other node or not. If it is pointing, then we move to that. Finally, we exhausted our words that we want to search, and all we have to do is to check if the final node has boolean value marked as true or not. If the boolean value is marked true, that means this word was inserted in the try. Otherwise, this word was not inserted in the try. There can be another case that maybe while we were traversing the nodes, starting from node 1, 2, 3, maybe at this position, this character, that is A, contains a null pointer. In that case, we quit and we say this word does not exist in this try. Let's see how we can implement this functionality. So it's very simple. All we have to do is to take a node, initialize this node with the root node, that is the first node of the try, iterate over the word, check if the particular children that is pointed by this word, that we are standing on the character. So initially we are standing on D. We check if D in this node contains a pointer or not. If it contains, then we move to the node which is pointed by the pointer present here. Otherwise, if it does not contain a pointer, we return false right from here, because we know this try does not contain this one. Hence, we keep on moving our node until we find the pointers here, and finally we reach the ending node and we check if this node contains boolean value as true or not to mark the end of this word. If it contains true, then the word is present, otherwise the word is not present. This is the case when we do not have any dots in the word. In case we have dots in the word, we have to improve upon our search function. Let's see how we can do that. Here we have a word that is .ad. We want to search if this word exists in the function or not. How would we modify the previous function to add this functionality? The question says we can replace this dot with any character. So if the dictionary contains dad, that is DAD, then this word would be validated. If the dictionary contains bad, then this word would be validated. So all we have to do is to just try to put all the words at this position and check if the resultant word is present in the dictionary or not. That's all. So we iterate over the word, we check if we encounter a dot. If we encounter a dot, we iterate over all the possible children, that is A, B, C, D up until Z, and we check if the remaining word, that is if the dot is present at ith location, then if the remaining word, that is starting from I plus 1 ending at n minus 1, where n is the length of the word, if that word is present in the dictionary or not. Okay, so if that word is present, so we encounter a dot, then we search if AD is present or not. If AD is present, then simply we can replace this dot with the character which is present in this node. So here in this loop, all we are doing is we are iterating over all the child nodes. Then here we are checking if the child node is not null. That means it is a pointer which is pointing to some other node. That means that particular character is present in that node. Then all we have to do is to check for the remaining substring if that exists in the dictionary or not. If it exists, then that means this dot can be replaced with this character, and hence we return true here. Otherwise we return false. Finally we check if, then this is the naive case where we are checking if the character C is present in this particular node or not. If it is not present, then we return false. Otherwise we move to the node which this node is pointing to. And finally we check if the ending node is marked true or not. If it is marked true, then we return true. Otherwise we return false. Let's discuss the time and space complexity of the search function. You can see that the time complexity for the search function is linear, because in any case we are traversing over the word at most once. The space complexity is big of 1 if we are not considering the stack space consumed. Okay, so let's try to implement the class in code. We take two classes. This is the try node and this is the word dictionary class. So let's implement the node first. The node contains a boolean variable to mark the end of a word. It contains 26 pointers, which points to 26 characters of an alphabet. Then this is a constructor which is used to initialize each node, where each node is not the end of any word. That's why we mark it as false, while we initialize these pointers to null. Now let's implement the word dictionary class. So the word dictionary class, a root node, a node from which we start searching or inserting any word. It contains a constructor which initializes the root with a try node, with a new try node. Then we have our addWord function in which we initialize a node to the root node. Then we iterate over the word which we want to search, and we check if the character on which we are standing points to some other node or not. If it does, then we keep on moving. Otherwise we return false. If it does, so here we iterate over the word and we insert each character into a new try node. Then we mark the end of the word as true in the final node that we created. Then we implement a function search which takes in the word which we want to search and the node. So this node argument basically represents the node number from which we want to search the word. For example, maybe we encounter a dot at the first node, then we encounter AD. So here, if I encounter dot, then I have to search for AD starting from second node, because the root node contains a dot which we want to replace with any character. So that's why I'm passing a node number here. Hence, we iterate over the word which we want to search, and I handle this condition where if the character is dot, if it is the case, then I iterate over all 26 children, and I check if a particular children can be put in place of a dot. If it can be, then I return true, otherwise I return false. Finally, this is the condition where I am moving to the pointers which my current character is leading to. If I found a node which does not contain a particular character of this word, then I return false right from there. Otherwise, I keep on moving until I reach the end. Here, I check if the word is complete or not by checking if the boolean variable is marked true or not. So that's how this function is working, and the class word dictionary is implemented. This is the implementation in C++. Let's see the implementation in Java. So this is the implementation in Java language, and this is the implementation in Python language. That's all for this video. If you like the video, then do like it and make sure to spread the word. I will see you in the next video.